Hello everyone, I'm Hasni and I'll be presenting a research paper for the cryptography. The title of the research paper is as follows: Security for Wireless Sensors Networking Using Cryptography, and the authors are Ramdevi I. Swami, Yella Surya Prakash, Chandru Anil Kumar, Vijay Kumar Sudha from VIT University and MVGR College of Engineering. Introduction. The paper basically uses VSN, meaning a wireless sensor network, which is used for various applications ranging from military surveillance, forest fire detection, and asset protection. The security is critical, especially when dealing with sensitive data. Challenges in the securing WSN is that they face numerous challenges including limited computational power, energy constraint, susceptibility to various attacks such as denial of serviceable and reply attacks. And the objective of this paper is is that it proposes a security framework using improved elliptical key cryptography for data encryption and decryption combined with cluster-based optimization using chicken swarm optimization. Literature survey. Seattle proposed an improved identity-based encryption system optimized for WSN which enhances network security while reducing energy consumption. And the other one introduced an identity-based aggregate signature scheme that maintains data integrity while reducing the bandwidth and storage costs of the WSN. And Sheetal presented a blockchain trust model for detecting malicious models in WSN, ensuring process traceability throughout the blockchain based on smart contracts. All such case studies have helped them to proceed with the further parts of the paper. Methodology used in this paper is an improved elliptical key cryptography. IEKC is a core cryptographic mechanism used in the proposed system. It employs elliptical curves for efficient key generation, encryption, and decryption. So, this cluster formation includes chicken swarm optimization and cluster head selection. Chicken swarm optimization is a biologically inspired algorithm that organizes nodes into clusters based on their fitness values. It mimics the behaviors of the chicken in a hierarchical structure where the roosters manage the hens. And cluster head selection CSO ensures that most suitable nodes are selected as a cluster heads, reducing energy consumption and enhancing the data security. So the key generation, there's public and private keys are generating using this elliptical curve cryptography, providing robust encryption. Each node stores its private key securely to prevent physical attacks. So the advantages of the proposed model is a high security. First of all, the IEKC enhances encryption security, making it more resistant to quantum attacks and physical node capture. The CSO based cluster formation reduces energy consumption by ensuring optimal resource use in the network. The model defends against common attacks like replay DOS and Sybil attacks. The encryption scheme ensures that even if a node is compromised, its sensitive data remains protected. The disadvantages of the proposed system is the complex implementation. The CSO algorithm and the IEKC involve complex mathematical operations which can be difficult to implement in a low powered sensor nodes. Overhead is that the performance of the encryption and the decryption for each communication increases the computation and the communication overhead. And the proposed model has not been extensively tested in the real world WSN environment, limiting its immediate applicability. And the current encrypted model is less effective for data types like image and videos, restricting the use to simpler data forms. And the scope of an improvement in the future is that it can focus on optimizing the encryption model to handle more complex data types such as videos, images, etc. And also the model should be tested in the real world WSN environment to validate its performance in the practical application. And optimizations are required, such as hardware acceleration could reduce the computational overhead in the power sense nodes. And combining the IEKC and blockchain or trust based models could further enhance the network security and provide multi layer defense mechanism. The the performance of the model is that the packet delivery ratio has achieved the PDR of 0.97, outperforming the other models like SLIM, LESPP, and there's a end-to-end latency also been evaluated. So the model end-to-end latency is up to 50 ms compared to 85 ms in the slims and 65 ms in the LESPP. And the throughput of the IEKC improved network throughput is that 365 kbps higher than the slim and LESP 352 kbps. And the encryption time for the model for 100 MB of data in 73 seconds faster than competing models like SLIM. Uh, the result shows that the IEKC model significantly enhances both security and efficiency in the WSN with a superior performance metrics in terms of PER throughput and latency. And IEKC outperforms other contemporary encryption models, making it suitable for sensitive WSN applications such as military and healthcare monitoring. Despite the promising results, real-time application testing and support for multimedia data remains major challenge for future research. And to move on to the summary, the proposed security model, which uses the IEKC and CSO, improves the overall security and the efficiency of the WSN by enhancing the encryption strength and optimizing the resource management. And the model provides a viable solutions to secure communication in WSN, especially uh, in mission critical applications where data integrity and security is of paramount. And the future research will focus on applying the model to real world scenarios and enhancing its ability to handle various types of data such as multimedia files and broaden its application scope. Thank you.